Hello and welcome to C++ Weekly. I'm your host, Jason Turner. Now, one of the things that I do is teach C++ best practices, and I just decided to record an episode that is directly related to the types of things that I teach, and this was not the episode that I was planning to record at this exact moment. But none of that really matters to you. The things that do matter to you is that this episode is going to be practical and interesting, and I hope that you stick around for it. The next thing is that I do teach workshops at conferences around the world. So if you can't afford to hire me into your company, or if your company doesn't have a budget for that kind of thing, then you should come to one of the conferences that I'm teaching a workshop at and attend said workshop. Okay, let's look at this. Now, this is an example that I created a long time ago. This is actually my default Compiler Explorer bookmark. Well, mostly I've modified a few things, but this particular example has a lot of bugs in it, actually. So let's go ahead and look at these bugs. Now, we're going to start by observing the fact that the compiler currently does not issue any warnings at all. And you can see that I'm building with -0. Now, if I were to turn on -03, even though I only have wpedantic currently enabled, and this is warnings that say that I am going outside of the C++ standard. If I turn on -03, I get a warning, this -w aggressive loop optimizations. Now, let's go ahead and start making a to-do list of things here. The point of this episode, oh my goodness, which I should have already said, but you saw it in the episode title slide, so that's not really relevant. This is how to apply warnings and static analysis to existing code bases. First thing that you should note: if you get different warnings between different optimization levels, you probably have undefined behavior in your program. We just observed that I went from 0 to 03, I get different warnings, I have undefined behavior. I don't even have warnings enabled, and I'm getting a warning from the compiler here. This -w aggressive loop optimizations, that's not a great warning. We want to fix that. And what it comes down to is, well, it says right here, iteration 5 invokes undefined behavior. This is really on the nose. You really need to pay attention to a warning like this. I have an array of 5 elements, and I am looping from index 0 through index 5, which means I am looping 6 times through the array of 5 elements. That is going to be undefined behavior on that last loop iteration. This is a pretty classic bug. If I turn this into a less than, then that warning is going to go away. I'm going to take one step back real quick. I want to do -w all, -w extra, -w unused. This is kind of the minimal set of warnings that I would enable, and this is 31 lines of code. If you don't currently do any kind of static analysis or anything on your code base, and you try to turn on W all, W extra, W unused, W conversion, etc., you're going to get an overwhelming number of warnings. So clearly this doesn't work. Let's go ahead and take this all out here, and we're going to back up, and we'll just have this thing that is generating a warning even though I am not asking for it. This is clearly a bug that needs to be fixed. So this is what I would recommend. I'm going to say, go ahead and turn on this -w error flag right here. I have now said this is a compiler error if I have this warning. And it really, really should be a compiler error. This is very bad. This is definitely undefined behavior. And if you're not familiar with it, undefined behavior basically means that I cannot trust this program at all. There's wording in the standard that says the compiler has absolutely no requirements placed upon it if the code has undefined behavior in it. So I've just made that an error, and now I am forced to fix all of the occurrences of this error in my code. Okay, I did that. I fixed that one thing, but now I also know it's impossible for that particular error to ever sneak back into my code base. Let's go ahead and turn on -w all. and you turn on W all and you get 1,000 warnings throughout your code base. And what do you do with this? I haven't even explicitly turned on W conversion or anything like that, but I've got this unused variable and I've got this signed unsigned comparison. This is actually really dangerous, regardless of what other people have taught you. This is bad. I am comparing a signed 32-bit integer to an unsigned 64-bit integer. If I get signed integer overflow, because this thing happens to have more than 2 to the 31 elements in it, which is absolutely possible with modern computers to have more than 2 billion items in a container, then I have like several levels of undefined behavior that are going to come into my code. By far, the best thing to do here is to use an algorithm, but maybe we're doing some sort of simple looping or whatever. So we can come in and I could do this, make this a size t, and I've just fixed that warning. But you've got hundreds of other warnings, so maybe you can't leave on -w all. That's too many warnings. But when we fix this one warning again, and I see this -w sign compare, I'm going to do the same thing again. I'm going to say -w error equals sign compare. Now I have decided that I am going to go ahead and aggressively fix this one particular error in my code. And I'm going to come back and I can make this a size t, but this is definitely not the best thing to do here. Far better is to make this into a ranged for loop. This just completely absolves us basically of the question entirely. We know that it's impossible to get that signed unsigned conversion. We don't even have to discuss whether or not this thing is going to be an int for its loop variable or a size t or whatever. We just use ranged for loops or whatever. All right. The key point being, I'm going to turn these things on one at a time. I'm going to turn on a warning. When I eradicate it, I make it an error. Therefore, it's impossible for this thing to ever come back into play. Now, this code, this rot32, actually does have undefined behavior in it. You can't shift by the size of a thing that's undefined behavior. This would trigger an error with undefined behavior sanitizer. But more to the point, I'm never actually using this value. Unused variables are a sneaky source of bugs in your code. Why did I do that calculation if I never intended to use the result? Why did I store this value if I never intended to use the result? Maybe this is where things really get nasty. What if I did this? And now in here, I'm accessing this. Now, this is bad code, really, but we're doing this to prove a point. So this variable is unused. This variable is not unused. I'm going to go ahead and turn on W extra real quick. Oh, I'm still not getting a good warning here. How about -w shadow? Shadow is a spectacular warning because it warns me when I'm shadowing inside an inner scope. This declaration of L shadows a previous local. Oh my goodness, did I intend to do that? Why did I ever declare this thing? So now I've got multiple levels of things that I want to fix. Let's go ahead and say, you know what? I'm going to attack the shadow error. So I'm going to go ahead and make that an error. And I'm going to say, why am I shadowing this thing? Why am I shadowing this thing? Well, this is unnecessary code. Let's go ahead and delete that. And then I'm going to come back and I'm going to get this unused variable error. Unused formally mentioned parameters is also another sneaky source of critical bugs in your code. Let's go ahead and do something with that. Oh, and see now, look, this is spectacular. This unused variable warning, which I'm guessing many of you have disabled in your code, I'm actually intending to print value here, but I'm accidentally printing val from the outer scope. Now, this is spectacular. So let's go ahead and we're going to say that we want to make are unused variables also an error? Now I have to go through and figure out, wait a minute, why is this variable unused? Oh, I actually meant to be using it here. And then I'm going to get a different unused variable error because that thing was unused. So let's go ahead and get rid of that. We're going to attack one warning at a time. Once I eradicate that warning, I'm going to make it an error. Don't just go straight out and turn on WAll, WExtra, WShadow, all of the things all at once, because you won't fix them. You just won't. It's human nature. You're going to do one thing at a time. You're going to make it an error. You're going to move on to the next thing. And this is how you will be able to introduce static analysis into your code base that currently does not have it. This is particularly relevant to a Patreon member who was just discussing in my Discord. So if you don't know that, you get exclusive access to my Discord where patrons can ask questions if you become a patron. They were just asking about this. And so this becomes the practical episode on how to deal with this kind of thing. All right, I'm going to wrap this up here. I think this is enough information on this particular topic. And I just want to mention that sneaky sources of real bugs are the things that people don't like and they tend to ignore, but you shouldn't. That is unused and that is shadowing. So thank you for watching this episode of C++ Weekly. I hope you enjoyed it. Be sure to subscribe. I'll catch you at an upcoming conference.